Okay, exercise. I want you to pause, copy this out, and give it a try. The hint is factor and then cancel. Factor, then cancel. Okay, here comes the solution. Factor. So on top, I have a difference of squares. You got a squared minus b squared is a minus b, a plus b. So on top, I have 5x minus 2, 5x plus 2. Because you'll notice over here that a is 5x, which is the square root of this thing. And then b would be the square root of this thing, which would be 2. Okay, on the bottom, I do a what I would call a product sum factorization. So looking at this trinomial, I'm looking for two numbers, m, n. They multiply to this times this. So the multiplication gives minus 10, and the addition gives the middle number 3. So put my thinking cap on, and I get m is going to be 5, n is minus 2. Now what do I do with that? I rewrite my trinomial by decomposing this middle dude using these two numbers. So the 3 becomes 5 minus 2. So I got 5x minus 2x minus 2. And then the factorization can be done by breaking into two grouped terms, two groups of 2 rather, x plus 1, and if I take minus 2 out, I get x plus 1. So now I have a common factor, x plus 1. You can take that off the front, off the back, doesn't matter. 5x minus 2. Okay. So my denominator is x plus 1 times 5x minus 2. And lo and behold, cancellations happen. Smiles erupt on faces across the nation. Math can be joyful. Where is x going to? X is going to 5 halves, 2 fifths. Oh, 2 fifths. Okay, so I had the limit was a problem to begin with. I didn't even check because I've getting lazy in my old age, but if you try to plug in 2 fifths at the beginning, you're going to get 0 over 0. Now with my factor and cancel fancy business, I have taken away my problem. My problem was 0 over 0, and that is gone now. So now I can just plug in my x is 2 fifths. And what do you get? 5 times 2 over 5 plus 2, and 2 over 5 plus 1. Work this out. On top you get 4. On the bottom you get 7 over 5, which would be 20 over 7. Next. How about this one? Pause and copy. Pause and copy. Now, I want to point out that this is 0 over 0. Okay, 0 over 0, so I cannot use my limit law. You know, you can't just go limit of the top over limit of the bottom. Okay, you can't do that because that limit law requires that these two things not have limits equal to 0. So I'm going to have to do some simplifying. So on top I have that and that. And on the bottom I got that. So I'm going to do the only thing I can think of doing, which is to do a common denominator upstairs. really I don't see any other ideas. Uh-oh, gotta put brackets here. Okay, when I do my common denominator upstairs, I've got to be careful. And lim always ends up in a weird place there. Let's rewrite it. There we go. So I did a common denominator upstairs. The common denominator was the product of the two denominators. So I took this times this, put it here, and then this times this, put it here. Hopefully a familiar operation. Okay, these brackets here on the 3 plus h are absolutely essential. Extremely common mistake is to drop them. Watch out for that one. Okay, another thing to watch out for is I have two horizontal lines here representing division. Be careful that this one is the bigger one. Okay, you'll notice that 2 over 3 divided by 3 is not the same thing as 2 over 3 over 3. Okay, they're not. Okay, you have to be careful with your division lines. Anywho, upstairs here, 3 minus 3 is 0. I get negative h over 3 plus h, all divided by h. Now I have a fraction divided by a number. The way I always do this is I turn the number into a fraction, so h over 1. Now h is the same as h over 1. And now I have a fraction divided by a fraction, and that's familiar. Well, I know what to do. I flip and multiply, right? So multiply by 1 over h, and I get what I want. The h is canceling. Why do I want that? Because that was the problem, right? That was h is going to 0. So these h's here are causing this to be 0 over 0. And when I cancel them, my problem is gone. And I can just plug in h equals 0 here. 3 times 3 plus 0, so negative 1 over 9.